Now when you look at this one, your first instinct is going to be to say f prime, using our shortcuts, is 2 comes down because of power rule, 2x minus 3 to the first. And that's your first instinct to say, yep, done. We'll hold that thought. Let's think. I can write f of x as 2x minus 3 times 2x minus 3. So let's do product rule. The derivative of the first function, so the derivative of this, is 2 times the second plus the first times the derivative of the second function, which is 2. So that's, let's see, 2 plus 2 is 4, 2x minus 3's, which if I distribute, if I want to, that's 8 minus 12, 8x minus 12. That's not what I thought it was going to be. If I just brought the 2 down and wrote 2 times 2x minus 3 to the 1, that would have been very different. Let's investigate. So I want you to do these. So write them down, do 4x plus 3 times 4x plus 3, and do product rule. See what happens. Pause the video. Wait for it. Do it. So you should be doing this right now. If you haven't done it, you haven't paused the video, you're not doing your job. So you need to pause the video and take the derivative. I left a little dead space there in case you were being a slacker. Okay, so I'm going to do it. It's 4x plus 3 times 4x plus 3. So that's going to be 4 times 4x plus 3, and then 4x plus 3 times 4. So that's going to be 4 times 4x plus 3 plus 4 times 4x plus 3. Well, 4x plus 3 times 4. So I'm going to say that's 2 4x plus 3 times 4's. Because there's a 4x plus 3 times 4 here and a 4x plus 3 times 4 there, so I have 2 of them. Similarly, if I have, let's change colors, if I have 4x squared plus 3 times 4x squared plus 3, you could multiply this out also and not do product rule. It's up to you. I think the pattern is going to be easier to see here. So the derivative first is 8x, 4x squared plus 3, and then 4x squared plus 3 times 8x. So again, I'm going to say I have 2 4x squared plus 3's times 8x. And then the next one's going to be very similar. So that's going to be 4x squared plus 3x times 4x squared plus 3x. So that's going to be, derivative of the first is 8x plus 3 times 4x squared plus 3x. And then 4x squared plus 3x times 8x plus 3, which gives me 2 4x squared plus 3's times 8x plus 3. You should be noticing something here. It's an interesting one, but you should be noticing it. You should be figuring out the pattern. Pause it and see if you can play with it. I have set all of these up in a very specific way, and I did it that way so that you could see what was going on. Now, I want to finish this because I think we need just like 1 or 2 more pieces. Maybe I just need to solidify it for you. Hopefully you figured out the pattern. If you haven't, here's what it is. If you have a function with a function inside it, and you want to take the derivative, you should recognize you take the derivative of that something squared by bringing the 2 down. So you take the derivative of the outside, leave the inside alone. That's why you have the 4x squared plus 3. That's why you have the 4x squared plus 3x, or the 4x plus 3. And then multiply this thing out here, you should notice, is the derivative of the inside, so that's g prime. So if you have h of x is 5 times 3x cubed minus 7x squared plus 2 to the 5th, then the derivative of that, h prime, this 5 will come down. So it's 5 times 5, which is 25. Leave the inside alone. Leave it to the 4th. So that's shmeh to the 5th. The derivative of that is 5 shmehs to the 4th. And then take the derivative of the inside. So the derivative of 3x cubed is 9x squared. The derivative of 7x is negative 7. And we did it. Now you've got to play with this. You have to, otherwise we're going to have problems. All right. I'm hesitating because I don't know if you need more explanation of what we just did. But I think I'm going to leave that and see what you can come up with. So let's start with a specific function you may know. Write an equation for all points 4 units from the origin. Okay? So if I'm 4 units from the origin, so 4 away, 4 away, 4 away, 4 away. Oh, look at that, it's a circle. So hopefully you know it's x squared plus y squared equals 4 squared. It's just the Pythagorean theorem, that's all it is. So now, vertical and horizontal tangents, I can pick those off. The vertical tangents are going to be at x equals 4 and negative 4. The horizontal tangents are going to be y equals 4 and negative 4. But let's go through some work. So let's go ahead and solve for y. So it's going to be plus or minus the square root of 16 minus x squared. Let's just consider the positive version. Don't worry about the negative version for now. And instead of the square root, actually I regret writing that, let's write it as to the 1/2. And let's use that chain rule we just had on the same last page. That's what we were just playing with, was chain rule. So y prime, the 1/2 comes down, 16 minus x squared stays to the negative 1/2, and then times negative 2x. So y prime is going to be half of 2 is negative 1, negative x over square root 16 minus x squared. Well, wait, square root of 16 minus x squared is just y, right? So it's negative x over y. So I could figure out what makes so to find the horizontal tangents, what makes this or this 0. That's going to be when x is 0. So that's y equals 4 and y equals negative 4. Sorry, my brain turned off. Vertical tangent, it's going to be what makes the denominator here 0. And so that's at y equals 0, which is at x equals negative 4 and positive 4. So those are your vertical and horizontal tangents. To find the slope at any point, well, we just did that, but there's got to be another way. So let's think. I'm going to write over here, x squared plus y squared equals 16. Let's just take the derivative directly. So what's the derivative of x squared? The derivative of x squared is 2x. What's the derivative of y squared? The derivative of y squared is 2y, but wait, we're taking the derivative with respect to y. So we need that dy dx, because that's that chain rule idea. If we have y squared, the 2 comes down for a power rule, y stays the same to the first, and then the derivative of the inside is going to be dy dx. And then the derivative of 16 is 0. Do algebra. Solve for dy dx, and you'll get to negative x over y. So that's called implicit differentiation. We're just using chain rule a little bit. And I think I want you to try this yourself. My hint to you, right here, think of this as x times y, because that's a product. But try it. and talk to me about it, about what questions you have. And any conclusions about implicit differentiation, I want to pull those together with you because I have a couple keys, but I want to see what you have so far.